So let me give you the definitions for sine, cosine, and then we'll do the secant, tangent, etc. I'll give you all 6. So 8 point, here it is. 6 point. Old book, it was chapter 8. The new book is 6.6. So inverse trig functions. Trigonometric functions. All right, so this is not going to be on the test, not till next test, but we're going to go ahead and keep going. So for I'm assuming you guys remember inverse functions from college algebra, but in case you didn't, this was the general idea for functions undoing each other if you compose them with their inverse. So if you compose an f inside the f inverse, they would cancel out basically, leaving you with whatever x was, the argument. And this would work for all x in the domain of f. F of f inverse is equal to x. So if you have it the other way, they still cancel, but the domain is only works for all the x's in the domain of f inverse. So the one that's inside is the one that you're paying attention to when it comes to the domain values. And we'll talk about what that means once we start doing examples. Okay, so that was like the general idea in college algebra when they first mentioned inverse functions. Now to define the inverse trig functions, they have to limit the domain, because you know how they repeat themselves forever, right? Sine, cosine, keep going. But the requirement for a inverse function is that it needs to be 1-to-1. So you force it to be 1-to-1 by limiting the domain. So here are the definitions of the inverse sine, cosine, and tangent. So inverse sine function y equal to sine inverse of x. So y is equal to sine inverse of x if and only if excuse me, if and only if x is equal to sine y. So basically you can convert it back and forth. Where your domain would be -1-to-1 on the x's for the inverse, and a range of -pi/2 to pi/2. Okay, so that's all we really need is this first part, that we can convert it, and we need to know the domain and range. So for test 2, I would make sure that you have that info somewhere if you decide not to memorize it. I'm not going to make you memorize anything. Inverse cosine function definition. So y is equal to cosine inverse of x if and only if, I'm going to use this abbreviation. IFF means if and only if. In mathematics, x is equal to cosine y. And the x will be between 1 and 1 as well, negative 1 to 1. This is my domain. My range will be the same as the other one. I mean, sorry, the domain is the same, but the range will be a little bit different. It'll be 0 to pi for cosine. Inverse tangent. Sorry. Inverse tan. So y is equal to tangent inverse of x if and only if x is equal to tan y. This domain will be all real numbers. And the range will be negative pi over 2 to pi over 2, but we don't actually include pi over 2 for tangent. So using these ideas, I'm going to make some formulas for you using all these definitions I just wrote. I'm going to try to simplify that way you know when to which x values will work when you have compositions of sine and sine inverse, or cosine, cosine inverse, etc. Make things a little easier. So these are my properties. Of inverse trig functions. Okay, so number one, if I have f inverse of f, right, meaning if I have sine inverse composed with sine, this will equal to x only if x, let's see, let me phrase this better. If x is between negative pi over 2, so here's the interval, to pi over 2. So if we're doing a problem in a minute, right? Let's say they had some number in here that was outside of this domain value, this interval, then you would say it does not exist, or domain error, or no solution. It has to be in here if the sign is inside. So we have it the other way. F of f inverse, sine of sine inverse. So this is true if x is between negative 1 to 1. Okay. Now let's do cosine. F inverse of f is equal to cosine inverse of cosine. So they cancel if x is between 0 to pi. And then the opposite, f of f inverse, cosine of cosine inverse is equal to x if let's see, yeah, if x is between -1 to 1. Now the tangent, almost done. We can start the examples. F of f inverse is equal to x. Oh, hold on. Yeah, tangent. Tangent inverse. Tangent is equal to x if the x is between pi over 2, but not including the endpoints. If it is the other way around, any x is fine for tangent. Okay, finally. There we go. So let's do some examples.
Oh, hold on, sir. Still writing. I'm sorry.
Yeah, I'm not turning the page just yet. Oh, wait.
By the way, for number 5 there, should it be like or equal to signs on the end?
On 5, no, it's not.
Okay.
Do not include pi over 2.
I'm good, sir. Thank you.
So let's look at these examples. It starts off pretty chill. Let me get the unit circle out first. I always forget where I put it. Oh. Yeah, it's over here. I have way too many folders now. Okay. So look at number 6. You guys see this, right? The arc's cosine. So find the exact value of the expression if possible. If not possible, enter impossible. So arc cosine is another way to write cosine inverse. I kind of prefer this one, but some books use the -1 symbol. The calculator uses the -1. Arc cosine, I think, is a little more clear what we're dealing with, but it doesn't matter. Use either one. But what the inverse function does, though, is that you give it a value, and it's going to spit out the angle where cosine is 0. Does that make sense? Because it's the inverse. So the original, you'd give it an angle, and it would give you a value. So let's go look at the circle. Right, we said the original cosine of 0. I'm sorry. Cosine of pi over 2 gives you a 0, right? For the x. So arc cosine or cosine inverse of 0 will give you the angle that makes cosine 0. that's defined in that section, right? We said that cosine inverse is defined between, we'll give you angles between 0 and pi. So it's only defined on the top half of the circle, because if they can't go any further because it starts to repeat itself and it's not 1-to-1. Okay, so they have to restrict it 0 to pi. So if we go back to that question, wherever the hell it is, oh, here it is. So it's asking you if which angle gives me an x value of 0? Well, that's pi/2. Does that make sense? Does
Not really, sir, to be honest.
Okay, so let's look at our circle and let's write it down. Okay. So you agree. So that's example 1. Arc cosine of 0, or if you prefer, cosine inverse of 0. That's the question they're asking us right now. We should understand that cosine pi/2 is equal to 0, right? You agree with that?
And that's because where cosine is 0 up at the 90 degree, that's pi/2.
Yeah, 90 degrees, pi/2. The unit circle tells us that cosine is 0, right? Based on the circle. So cosine, what cosine does, it takes an angle and gives you an x value. What cosine inverse does, or arc cosine, it takes a value and gives you the angle where it happened. So this happens at pi/2. Because it's an inverse function. It reverses the range and domain. So the outputs become inputs and the inputs become outputs. So this input outputted a 0. So now it's telling us, well, if I have an output of 0, what was the original input? Well, it's this. That is all they do, the inverse functions. Does that make more sense or no?
Not really. Like, I kind of have trouble reading the unit chart circle thing.
Oh, you don't understand the circle?
Like, if I'm being honest, yeah, screw it. I'll be honest.
Okay, and let's go through it, because the circle is important. So let's make sure we understand, right? So every single x value here are cosine values, right? All the way through. So when I do cosine of 30 degrees, the x value is what it's going to output. So cosine receives a 30 and outputs √3/2. Cosine 45 receives an angle of 45 and spits out the x value. Cosine 60 gives me this x value. It goes all the way around. And then the sine is going to be, sine of 30 will be the y value. Sine of 45 is this y value. So all the way around, it will be all the y values. That's what sine does. You just give it a angle and it gives you an output. So these are actually, how do I phrase this? Points, right? So you can kind of build your little triangle here and say, well, if I were to create a triangle, I can actually find these values like we did before. Remember how we had the definitions of sine and cosine, opposite over hypotenuse, all that stuff is basically the same thing. But the easiest way to think about it is that, you know what? They are common values from the circle. Cosine is the x, sine is the y. Tangent is the ratio of y over x. So you just divide them. Right? 1/2 divided by this would be the tangent of 30.
So one more time, how do you explain tangent using this? You divide the y by, I mean, you divide the x by the y to get tangent?
Right. So
Got it. Okay.
yeah, so like if we say what is tangent of, it's just a random example, right? No, tangent of 30. That's the same thing as saying sine of 30 over cosine of 30, right? That's the definition of tangent, which is the same thing as saying y over the x, right, from the circle. So what is 1/2 divided by square root 3 over 2? So you do your math here. That'll be 1/2 times 2 over root 3, leaving you with 1 over root 3. And then you have to rationalize, which will give us the actual answer that we're supposed to know, I guess. Right, this is, I don't expect you to memorize it, but this is one of the common values of tangent.
3 over 3?
Square root 3 over 3.
Okay, I just wanted to understand it.
What's up?
I just wanted to understand it.
No, I'm glad you asked, because I mean, test is coming, so this is the time, right?
Thank you.
I don't want you to go in there not knowing something. Okay, so that's what the unit circle does. Anyone else have any questions on the circle? Right, you input values and you get an x for cosine and a y for sine. So the inverse function does the opposite. You plug in a value and it tells you what angle it happens at. So looking at our circle, arc cosine of 0 would be, arc cosine of 0 is going to be pi over 2. So basically that means what angle gives me an x value of 0? That's what that means. So if I would have done arc cosine of 1/2, like, okay, well that happens at pi thirds. That's the location where it gives me an x value of 1/2. So we're just doing it backwards, basically. Let's see here. If we have a definition that could help us, maybe. So the definition earlier, we said, where is it? For inverse sine, we said that before we start, y is equal to sine inverse of x if x is equal to sine y, right? So we said earlier, part of the inverse sine definition. So if we have a question, this says sine inverse of 1, which is the same as arc sine of 1. So that means I can rewrite the inverse. So let's say I want to know what this is. What is the x, or sorry, what is the y value, right? That's the question. Not y. What's a better way to say it? Yeah, what is the angle theta? I think that's more clear. What is the angle that will give me 1? If I use the definition and convert it, that's the same thing as saying that what theta is equal to 1 for sine. I feel like this might be more clear once you change it, right? What angle will make sine 1 on your circle? Yeah, it has to be pi over 2, right? If we look at our circle, sine of pi over 2 gives me a 1 for the y value. So that's what this question is asking. What angle gives me 1? Sine of some angle gives me 1. These are the same. These are logically equivalent. It's the same thing. Is there any question about that?
Could you say it in plain English, like one more time?
So just in plain English, the question of which angle will make the sine value 1, which angle makes the y value 1, is the same as saying sine inverse of 1 equals to theta, some angle. These are the same.
So basically is like the, whatever this is called,
Inverse functions.
there we go, inverse functions. Just asking where does it make this number?
Yeah, pretty much.
There's a better way to say that, but
Yeah, you're just going backwards because for the last few weeks, we've been going and we've been saying cosines the x and sines the y, right? We've been saying that for a while now. But now the inverse is just saying, okay, we'll go backwards. If I give you the x, what is the angle? If I give you the y, what is the angle? Depending on sine or cosine. That's it. Let's do another one. Where is it? Okay, here it is. So the question, sine inverse of square root 2 over 2. So when is the y value square root 2 over 2? What is the theta, the angle that does this?
pi over 4.
Yeah, exactly. So if you were to use a definition, that's the same as saying sine theta. There exists some angle that makes the y value square root 2 over 2. So we go look for it. If we don't have it memorized, we just look up the circle. Where's that damn thing? You say, okay, well, here's the y value. That angle is pi fourths. And that's all you do. You just need to remember where is sine inverse defined, right? So that's why I wrote all those details earlier, because you have to make sure this isn't out of the domain or range.
So, sir,
Mhm.
for that example, so the actual answer would be 45 degrees?
Yeah, the answer would be the angle they're looking for would be pi over 4 or 45 degrees. One of these. So that's my theta, I guess. So that's what, so when you look at these questions, it's the same thing. Let's look at this one, number 6. It says sine inverse of 4 or arc sine of 4. What is which value on the circle gives you a 4? Does that ever happen? Now, you see the issue there? What was the domain of sine inverse? The first definition we wrote. Yeah, -1 to 1, right? So we said. So you see how the 4 is bigger than 1, correct? It's outside this domain. So it's not possible. Another way you can spot that is the circle is literally unit 1, the unit circle. It never goes beyond 4 or beyond 1. So it's never going to be 4 for sine. So that's too big. It's not going to happen. So two reasons. It's outside the domain and it's too big for the circle. It's impossible. So make sure you, when you're doing these, you're always looking at the domains to be safe. Let's do another one here. I think that's another one. Again, too big, right? Let's do number 11. Right, what is the angle that makes it -½ That makes cosine -½ The arc cosine of -½ or if you prefer the inverse symbols, cosine inverse of -½ They want to know what is the theta. What angle gives me a cosine or an x value of -½ All right, using our definition, that's the same as asking cosine theta. There exists some theta that makes it -½ Right. So look at the circle again. When am I -½ Looks, here's where cosine is -½ That angle is 2 pi-thirds. So I look at the x because they said cosine inverse. If they would have said sine inverse, then I'd be looking at the y's, right? I would have chosen this one if it was -½ for sine. So our answer, right? Our answer theta is 2 pi-thirds. Any questions on number 3? Is that okay? This, let's look at values that are not on the circle. So here we kind of have to use a calculator. So you would just punch in sine inverse. See how there's an inverse button right above the sine and cosine. So you'd have to hit, if you have a TI, you'd have to hit second sine. Oops, that's not right. Oh, yeah, you hit second sine, I think, on the 84 or 83. On this one, you have to hit sine twice. Once you hit sine twice, you punch in the -0.57. That's about it. You'll get an angle. So this is the angle rounded to 2 decimal places. It's -0.61 here. This one you should see right away. It's impossible because it's bigger than 1, right?
Wait, sir, how did you do that on the calculator? I'm sorry.
You have this one, right?
Yeah, I have the small one.
So just hit sign and then hit sign again. See how it changes to -1?
Wait, let me see if I can do it on mine really quick. So sign and then sign again. Oh, yeah, I do. Okay.
And just punch in
you.
the number and you're good.
Thank you.
So whenever they have arc, use sign inverse. Simple. Okay. Let's do number 16. That one looks kind of weird. Okay, so they give us a triangle and they say example 4, thought it was. Yeah. Use an inverse trig function to represent theta as a function of x. So all they really give us is a triangle. They put theta right here. They put 3 and x right there. So they basically want you to solve for theta. So there's two ways you can think about it. I think the easiest way is to create the tangent function first, because we know tangent of theta is equal to opposite over adjacent, right? That part's clear. So if you want to solve for theta, you'd have to cancel the tangent. So you would have to use tangent inverse of both sides to cancel tangent. Remember we wrote those definitions at the beginning? If you compose something with its inverse, they're going to cancel. So theta would equal tangent inverse of x over 3. So theta is equal to a function of x. That's what they want. They want you to solve for tangent. Or sorry, for theta. They want you to solve for theta.
And the answer is just that formula?
Yeah, they want you to solve for theta. So theta is tan inverse of x over 3. That's what they do to get to solve it.
Oh, sir, could you scroll up real quick on that?
On
Not there, on the
homework?
other. Yeah, I wanted to see if I got that answer right for the arc sign because I didn't get a chance to write it down.
Oh, sure.
Oh, that's not what I got. I got like negative 34.75.
Are you in degrees or?
Oh, I'm not sure.
Because this is
That-
radians.
Well, it wasn't the answer I got though, but I'll figure it out later.
Yeah, change it to radians and then try it again. Do you have any questions on number 4? Example 4? '17 is the same thing, but we can go ahead and do it. use an inverse trig function. To write theta as a function of x. So given this triangle, okay, let's switch back. Just create the cosine function. So cosine of theta is equal to adjacent over hypotenuse. Solve for theta by canceling cosine. Using the inverse trig or inverse cosine, theta will equal this function. You guys cool on 4 and 5?
The actual answer is just cosine -1 3 over x.
Right. That's what they want. Okay, number 19. See how they're supposed to cancel out? Tangent of arctan, you're left with x. In this case, x is 37. So they will cancel as long as this value is within the domain. So you have to look at those formulas I wrote at the beginning. We said in this combination, x can be anything, so you're good. Over here, cosine of arc cosine of -√2 is impossible because, let's go look at the values we wrote. We said at the very beginning, cosine of cosine inverse will cancel, leaving you with a value if x is between -1 and 1. Our x in this question is -√2. How big is -√2? That's a decimal. I mean, this is like -1.8 or something. I don't know. Let's see. -√2. This gets, I forgot to change it to decimals. There it is. Yeah, -1.4, not 1.8. But either way, it's too small. It's below -1. So that's why it is impossible. So you have a few of these. Some you have to adjust because they are outside the domain. So you have to find like a reference angle. Like let's do 22, right? So we know that this should cancel out and give me the value, but they want only pi/2. Like, why is that? So let's look at our circle. And we said that cosine inverse is defined from 0 to pi, right? So I'm only going to get outputs on the top of the circle. 3 pi/2 is down here. So you'd have to adjust and use this angle for pi/2. Let's look at the question again. Yeah, so negative, oh, this is negative 3 pi over 2, actually, sorry. So that's the same as saying negative 270, right? Meaning instead of going all the way to 270, I would go negative 270 in this direction and end up at pi over 2. So you use the positive version. Does that make sense? So if I had negative 270, you would add 360 to adjust it, because this one is in the range for cosine inverse. If we look at the definition, right? We said it must be between 0 and pi. That makes sense? Okay, let's do something that's more difficult, because these were all matching. You know, notice that cosine and cosine, sine inverse and sine, cosine and cosine inverse. These are all matching. So we had those formulas that we were on the first page. So all we had to look for was, is it too big or too small? If it's not, you just write the number. If the angle was outside the range, then you have to adjust and pick the normal one. But these are a little harder, because notice how it's doesn't match anymore. It's cosine arcsine. So we're gonna have to draw a triangle. So these are a little weird. So let's do 24. Okay. Write an algebraic expression that is equivalent to the given expression. So basically we need to create triangles to help us out. So cosine of arc cosine of 3x. That's the same, I'm sorry, that's actually sine right here. Okay. So arc sine, or if you prefer, sine inverse of 3x, that's the same as saying, so we want to know what theta, right, gives us this. That's the same as saying that there exists some theta equal to 3x. I don't know why I wrote it way over there. So this is this way. So using this fact that came from the inside, right? Draw a triangle and find cosine. That's what the question is asking you. So this is by definition, this right here. I didn't do anything special. That is just a definition. So using this fact here, create the triangle. So we know this is opposite over hypotenuse, right? So opposite of my theta that I chose to put here, hypotenuse will be 1 because there's always a 1 down there. We need to solve for the adjacent side. Adjacent side will be, using your Pythagorean theorem, 1 minus 9x squared. Right, if you do the Pythagorean, you'll solve this. Would you like to do that together, or do you remember the Pythagorean theorem?
A squared plus b squared equals c squared.
Yes, we're just solving for b squared, or just you square root b squared and you get this. So once you do that, what is the cosine using this triangle? That's what they're really asking. Cosine is adjacent, right? Over hypotenuse. I'm going to do the Pythagorean theorem right here, just in case. So let's say that this is my A. Solve for B. B would equal 1 minus 9x squared. Square root both sides. B is equal to square root 1 minus 9x squared. So once you have the adjacent side, you answer the question. The question is basically asking you, what is cosine given this information? I think that's the easiest way to think about this. Any questions about that?
You said, what is cosine given this information?
Right.
Okay.
That's the way I think of it. Because when I first did these, they were very confusing. I was like, so we need the triangle to answer the question, but trying to decipher what the information is saying requires the definition. So it's like I'm saying, right. This is really what they're asking. Like, what is this? Right. Find this. It's just that theta is equal to arc sine of 3x, or if you prefer, sine inverse of 3x equal to theta. Same thing. So we use the definition to change it to get sine of theta equal to 3x. Once we have that, we know that this is opposite over adjacent. And with that information, I can solve for adjacent, which is what I did here. That's what's happening. Does that help a little bit? I think it'll sink in more if once you start reading the definitions, if it's not at the moment, but. Anyway. I'm gonna delete some of these weird questions real quick. Yeah, I don't like that question. Yeah, that's fine. Okay. All right, you guys have any questions about 6.6?
Not yet.
All right, well, we'll stop here and I'll let you guys focus on the exam. So I guess on Tuesday, if you want to bring some questions on 6.6, that'd be great.
I probably do have questions, but I don't know what to ask.
Yeah, I think you need to get into the weeds first. Once you start trying to solve them, I'm sure you'll have thousands of questions. All right, guys. Well, I'll see you on Tuesday. If you guys have any questions, let me know. If not, I'll see you later. I'll stick around for a little bit.
I do. Actually. Sir,
Yeah.
I was going through some homework